Okay, let's look at section 5.5, fractions and decimals. So we can convert our fractions to decimals just by dividing. So basically, the easiest way to do it is reduce your fraction to lowest terms first, and then when you divide, it'll be much easier. If you have a huge number divided by a huge number, that's going to be a lot harder than if you can reduce it down to a smaller number over a smaller number. Now we have two types of decimals usually, terminating decimals and repeating decimals. Terminating decimals, you can reduce fraction to lowest terms, and then if the denominator has a prime factorization with only 2's and 5's in it, the decimal will terminate. So it'll become like 0.325 or something. It'll stop. You don't have to go any further. The remainder will be 0 when you divide. But if you have a repeating decimal, what happens is once you reduce it to the lowest terms, the denominator is going to have a prime factorization with numbers other than 2 or 5, usually like 3 or something like that's going to be in there, and that's going to make it so it doesn't terminate. It's going to repeat. So like 2/3, that's going to be 0.666666, repeating on forever and ever. All right, so as it says, repeated patterns will appear after you do the division, and it just depends on how far out before it actually repeats. Now, if it does repeat, we have a thing called the repeating bar. What we're going to do is we're going to find the part of the decimal that repeats and place the bar over the block of digits that repeats. And that just means it repeats indefinitely. So if we have 0.53 with that repeating bar, that means 0.5333333, and so on until forever. And what it is that 3 is repeating, so we put the 3, have the bar over the 3. Now with this one, the bar is over the whole part. So what's going to happen is it's going to repeat 14382, 14382, 14382, and it's just going to keep doing that over and over and over again. And so that's the piece that repeats. Now, when we do this, if we come up with a decimal after we divide it, what we're going to do is we're going to put the bar over as few digits as possible. So in the case of 1/3, we're going to put it over the 3, just the 3 here. That'll be the correct way. We don't want to put it over 3/3 because that means we're going to have 3/3 repeating every time, but we can actually break that down to something smaller, and that's just the 0.3 there, and the 3 has the bar over it. Now, we can also have problems sometimes that'll contain both a decimal and a fraction. And so the key is to change everything to a fraction if a decimal will contain repeating digits. Otherwise, we convert it to a decimal. So like in this case, 2/3, when we convert that to a decimal, that's 0.6 repeating. And so then if we add that to 0.25, that's pretty much impossible to do because you have that repeating 6. And so we're not going to do it that way. But what's going to happen is instead, we're going to convert our decimal to the fraction and add them together. So 2/3 plus 0.25. Well, if you think about that, what is 0.25? 0.25 is a quarter because what we really have is 25 over 100. So this can be converted into 25 over 100 because we have the 25 hundredths. That's what that is equal to. Now 25 will go in here 1 time, 25 will go in here 4 times, and so we get that 1/4. And so then we can add those two together by getting a common denominator of 12. So we'll take 4 times this and get 8 over 12, and we'll take 3 times that and get 3 over 12, and then 8 plus 3 is 11 over 12. And so that's what we're going to do if this is going to be a repeating decimal. Now, if this is a terminating decimal, we'll convert them to both decimals and we'll just work with decimals only. All right, so let's do some examples where we convert a fraction to a decimal. And all we do, again, is just divide. So we're going to take 5 into 19, and I'm just going to add some zeros there. I don't know how many I'll need, so I'll put my decimal above the decimal here. 5 goes into 19. 3 times will give us 15. If we subtract that, that's going to give us a 4. Now we bring down our 0. 5 will go in there 8 times because that's going to be 40. Now if we subtract that, we get 0. And so our decimal is just going to be 3.8. And that's all we have to worry about. We're done. It terminates and we're good to go. Now this one is going to be a little bit different because now we have to take 125 into 7. So that's a very small number. So we're going to have to add a lot of zeros there, I think. And 125 goes on the outside. So 125 into 7 point. And then, like I said, we'll have to add multiple zeros. I don't know how many. Well, it doesn't go into 7. Doesn't go into 70. It'll go into 700. Well, let's take 125 times maybe, I don't know, 6 and see what we get here. So if we do that, we get 30. That's 12, 13, 14, 15. That's 750. That's too big. So let's take 125 times 5. So that's going to be 25. That's 10 plus 2 is 12. That's going to be 6. So that's going to be a 5 there. And so that's going to be 625. Subtract that off. Well, there's 75 is the difference there. Bring down the 0 from there. Well, we already know 6 works here, so that'll be a 6. And that's going to be 750. We subtract that, that gives us 0. So this is 0.056 for our decimal of 7 and over 125. Okay. All right. Now, what are we going to do? Let's go ahead and see what's on the next page. And now we're going to convert to decimal. Now, notice these, we could just divide it out. 180 goes into 268. But I think if we look at this, well, 2 will go into here. Well, 2 will go in there, 1, 3, 4. 2 will go into here, 9, 0. Okay, so that's going to give us 90. 2 will go in here, 1, 3, 4. Now, guess what? It's going to divide again by 2. So 2 will go in here, 6, and then a 7. 2 will go in here. That's going to be 45. So 67 over 45. I think that's as far as we can go. So now let's do the division of 45 into 67. Let's go ahead and add some zeros. I'm not sure how many we'll need. Let's add that. It goes in once. That's going to be 45. Subtract that off. 7 minus 5 is 2. 6 minus 4 is 2. And then we bring down our 0. And 45 times, let's say 4. That's going to be 20. That's going to be 16, 17, 18. Well, if we add another 45, what does that give us? That's 5, that's 12, that's 2. So that's too big, so it's just going to be a 4. And so that's 180. Subtract off, that's 0. We carry, that's going to be 4. Now we have a 0. And so 45 times, let's see, 8 is going to be too big. How about 6 and see what we get there? It's going to be too small, I think. So that's 30. That's 27. Yeah, let's go 45. Oh, wait, times 8. That might work. That's going to be 40. That's going to be 32, 33, 34, 35, 36. So it looks like that will give us 8. We have 360. Subtract. It's going to be 4, 0. And notice we had 4, 0 here. We have 4, 0 again. So that's going to be 8. And it's just going to keep repeating 8, 8, 8, 8 as far as we go, it looks like. And so because of that, what we can do then is we can say, well, this is going to be a repeating decimal. And so that's going to be 1.48. And because 8 repeats, we can put our bar over that, and we have 1.48 repeating. All right, let's try our next one. So 102 and 396 both look like they can be divisible by 2. Well, so 2 will go in here 51 times. 2 will go in here 1. That's 119, so that's going to be 9. That's 18, 1, 6, that's 8. So that looks like it's 51 over 198. All right, so now can we reduce that any more? 6, that's 9, 8, 9, 18. Looks like we might be able to reduce that into by 3 because both of them are divisible by 3. So 51 divided by 3 goes in once, and that's 21. So that's going to be 17. So it goes in 17, and 3 will go into here. 3 goes in there, 6, that's 18 and 6, so 17 over 66. All right, so that can't be reduced anymore. So let's take 66 into 17.000, however many we need. So that goes in 0 times. Now 66 times 2, that's 12, that's 132. If we add another 66, that's 190. So it looks like 2 will work. So that's 132. Subtracting that off, that's going to be a 6. So 10 minus 2 is 8. 6 minus 3 is 3. Now we bring down a 0. All right, so 66 times 5, that'll be 30. That's going to be 33. And another 60 is going to be 390. So that's as far as we can go. So that's a 5. So that's 330. Subtract that off. What's a 0? That's a 5. Now we bring down another 0. All right, so 66 times 7. Let's see what we get there. That's going to be 42. That's 42, 43, 44, 45, 46. So if we add another 66, that's 5 over 5. So we'll say it's a 7. So it's 462. Subtract, what's a 4? It's a 9. So 10 minus 2 is 8. 9 minus 6 is 3. Oh, look at that. That's where we were at that point. So what we can say is this is going to go back to 5, and then it's going to go to 7, and then 5, and then 7. So that 5 and 7 is the repeating part. So it looks like 2, 5, 7 with a bar over the 57. Okay, and so that would be our fraction converted to a repeating decimal in this case. All right, so now we need to determine first if it's a terminating or a repeating decimal, and then we'll either convert everything to a fraction or we'll convert everything to decimal and then do that. So remember, 2 and 5, if we go back to our first slide, 2 and 5 will give us terminating. Anything else will be repeating. So here we have a 2. Well, this is 2 times 2, so both of these are terminating decimals. So that means we're going to have to convert them both to decimals. So we'll take 2 goes into 3. Well, we should know that's 1.5 already, but we'll go ahead and do the division. So that's going to be 1, bring down a 0. That's going to be 10, subtract that, that's that. So it's 1.5 then. Oops. And then that's minus 2.73. All right, so when we have one decimal bigger than the other one and they have opposite signs, we'll take the larger, 2.73, minus the smaller, 1.50, because we can just add that 0. We line up our decimal, so we know it's going to be here. Now 3 minus 0 is 3, 7 minus 5 is 2, 2 minus 1 is 1. We know the sign of the larger is negative, so then that tells us our answer is negative 1.23. Okay. Now, similarly here, we have to divide first to get our decimal. So 4 goes into 7. Well, that goes in once, that's 4. Let's go ahead and add some zeros here. And so subtract that off, that's 3, 0. So if we take it times 7, that'll give us 28. Subtract that, that's 2, 0. Well, that'll go in 5 times, and that's going to be 20. Subtract that, that's 0. So it looks like a minus 1.75 plus 3.3. So again, what we have is we have a larger number that's going to be first, 3.3. And we can go ahead and add that extra 0 because we have 2 decimal places here. We'll subtract off 1.75. Now our larger number is positive, so it means our final answer is going to be positive, so we don't have to worry about that. So 3 goes down, we borrow there, and we have 2. We borrow here, that's 12. So 10 minus 5 is 5. 12 minus 7 is 5. 2 minus 1 is 1. And so we should get 1.55 for our answer in this case, where we take the negative 7/4 minus or plus the 3.3. All right. Let's go ahead and see if we have another one here. Now, guess what? 6 has 2 times a 3. So that is going to make this a repeating decimal. Now this one is 2 times 4, which is 2 and 2. So that's going to be terminating again. But this one repeats. So because that repeats, we have to convert this decimal to a fraction. All right, so let's go ahead and think about that. That's going to be, if we move the decimal over 2, 1, 1, 2, over, now we should have 1, 2 zeros, 1, 2 zeros. And so that should be our fraction. But I think we want to kind of reduce it a little bit because 100, getting 6 to 100, that's going to be a little more difficult. So if we divide both of them by 2, that'll be 50. And 2 goes into there, that's going to be 5. And then 1, 2, that's going to be 6. So that's going to be 56 over 50. Now we can reduce again by 2. and that goes in 25 times. 2 goes in here. That's going to be 2. That's going to give us 4, 1, 6. That's going to be 8. So that's going to give us 28 over 25. All right, so that looks to be as good as we can get as far as reducing it as much as possible. All right, so now what we really have is a negative 11 over 6 plus 28 over 25. All right, well, 6 we know is 2 and 3. 5 or 25 is 5 and 5. So our LCD is 2 times 3 times 5 times 5, which is basically 6 times 25. Well, 6 25s is going to be 150. So if we take this one, what we're going to do is we're going to take a negative 11 over 6 times 25 over 25 plus 28 over 25 times 6 over 6. And so let's kind of keep our space here. And so now we have to take 25 times 11. So that's a 5, that's a 2, that's a 5, that's a 2. So it's a 275. So it's going to be a minus 275 over 150 plus, now we have a 28 times 6, so it's going to be 48. That's 12 plus that's going to be 168 all over 150. All right. So now what does that give us? Well, now we have to subtract. So we're going to take 275 minus 168. And when we do it, our answer is going to be negative because our larger one's negative. So we have to borrow. That's going to be a 6. So 8 and let's see, 7. That's going to be, oops. All right, 8 and 7 will give us the 15. 6 minus 6 is 0. That's going to be 1. So this is going to give us a negative 107 over 150. All right, so that's what we have there. Now, do we want to reduce it anymore? Because I think what's going to happen is we're going to get a repeating decimal again because we still have that 3. So I would say that's going to be our answer, and it's going to be in lowest terms, and so we don't have to worry about anything after that. All right, now back to this one. We said it was going to be a terminating decimal, so let's go ahead and divide it out. And when we do that, we go 8 goes into 13. We'll go ahead and add some zeros. Goes in ones. Subtract, we get 5. Bring down a 0. That's going to be 6. 6. So that's going to be 48. Subtract that, that's 2. Bring down another 0. That's going to be 2, so that's going to be 16. Subtract that, that's 4. Bring down another 0. Looks like I put the right number of zeros for once. Now 8 times 5, that's going to be 40. Subtract that, that's 0. So what we have is 1.625 plus 8.4. And so what we just do is we take 1.625, 8.4, add a couple of zeros. We're going to add those together. So 5 and 0 is 5, 2 and 0 is 2, 6 and 4 is 10. Carry the 1, 8 and 2 is 10. And so this looks to be 10.025 for our answer. So notice when we had the repeating decimal, we went ahead and left it into the format of the fraction. But when we had the terminating decimal, we went ahead and made it into a decimal itself. All right, so that's all I have for the lecture. I'll record a couple of example videos in a little bit.